Hi everyone, welcome to the fourth and final part of section 7.2, Simplifying Radical Expressions. We're going to dive right in and we're going to I'm going to model a problem for you. So essentially what we want to do is we want to try to see if we can ever simplify radical expressions, kind of knowing that there's a tie between writing something in exponential form and something in its radical form and vice versa. So in the problem that we have here, we have the cubed root of AB is being raised to a 15th power. So if I were to rewrite this, essentially what I'm going to do is I'm going to take this from, I'm going to take my cube root of AB and I'm going to take it from radical to exponential. So in other words, when I rewrite this, I'm going to take my 3 and I'm going to move it to its denominator position. This is going to give me AB, and again, we're going to group that, and we're going to raise that to the 15th divided by 3. But what are you noticing about the fraction that we end up creating when we translate this into its exponential form? Hopefully you're noting, well, I can simplify 15 divided by 3. This is going to give me AB, and that's just going to be raised to the 5th power. And technically you can leave it here if you'd like, or you could kind of flesh it out a little bit more and you could do a to the 5th times b to the 5th. They are saying the same thing, so both of these are acceptable for that solution. So what I would like you to go ahead and do is we're going right into practice problems, and some of them are a little bit different. So what I would encourage you to do is, again, see what you can kind of uncover. I'm not expecting you to be able to solve them all perfectly, but what I do want you to do is see if you can at least kind of come up with a first step before reviewing the solutions that are going to follow immediately after in this video. Okay, hopefully you've had some time to practice. We're going to take a look at the first two here. So again, the first one that I have here, my goal is I want to use rational exponents to help me simplify. And where possible, if I still have something kind of left over, if I still have an index or a denominator, I want to rewrite this back into its radical form. So for my first one, I note that I have a 4th root. So I'm going to send that to its denominator. And that's going to give me y raised to the 40th divided by 4. And again, what I want you to note is we have a 40 divided by 4. I can simplify that. That'll become y to the 10th. Okay? There is note, or I guess I should say, we'll notice that the index is just 1. I almost said there is no index. That would be incorrect. I'm saying that my index is 1. And we don't work with a first root. We only work with square root, cube root, and so on. So my final answer, I can just leave it as y to the 10th. So let's go ahead and move to the next one. Here we have the 8th root of 3x, all of that being squared. Same deal. Here's my index. I'm going to send it into its denominator just so I can see what might happen. So I still have my 3x squared, and we're going to have 8 sitting in the denominator. I want to focus my attention on this fraction. Can I reduce it? And hopefully you're saying, yeah. You would have 3x, this time raised to the 1/4. And since I have an index bigger than 1 in that denominator, I'm going to move it back into its radical notation. So in other words, I'm going to kind of go in reverse. I'm going to take that 4, and I'm going to kick it back. So now I have a 4th root with just a 3x underneath it. As long as you can kind of clearly see that the 3 and the x are underneath the root, you can leave it like so. If you want to be super careful and put parentheses around it, that's also fine. Let's go to our next problem. Okay, so it's very similar to the ones that we've been working on. We just have 2 variables that we have to contend with. So if you're feeling a little anxious, just kind of hang back, make some good notes for yourself, so then you're going to hopefully be a little bit more prepared when you do the homework. So again, what I'm noting, I have a cubed root, so I'm going to send it out. So this is going to leave me with x squared y to the 5th raised to 12 divided by 3. And again, focus your attention on that root. Or sorry, not root, the exponent. 12 divided by 3. What can we get from that? And hopefully we're saying, well, x squared raised to the y5th, now raised to the 4th power if I simplify that down. Remember your rule in this case. So I no longer have a denominator that's bigger than 1, so I don't have to worry about it anymore. But I can clean this up. I mean, I can share out that power of 4 to both the x and the y. So that would give me x squared raised to the 4th power times y to the 5th raised to the 4th power. And that comes out to x to the 8th, y to the 20th. And that's as far as I can go. The last one is really, it was super challenging, and I'm not necessarily going to expect you to have to reproduce this on a quiz or an exam, but I did want you to kind of play with this one and see what you could do. So to take you through this one, the first thing that I'm going to note is, well, maybe I'll work from the inside out. So I'm going to focus my attention on the square root of n here. And I know that it has an index of 2. This n has an exponent of 1 because I can't see it. So the first thing that I'm going to note, underneath that 6th root, I have an n raised to the 1/2. Now, this should look very similar to what we had just looked at. So I have a 6th root, and I'm going to send this out. Okay? So now I have n raised to the 1/2. And actually now I have it divided by 6. That's kind of a gross looking complex fraction. Not fun, but again, here's where the challenge lies. I'm going to do a little bit of an aside, and I'm just going to focus on this nasty looking fraction. So I'm going to do this down here. So I have 1 divided by 2 divided by 6. That is just, it's horrible looking, right? So we can rewrite this. So I'm going to treat this as 1/2, and then I'm going to treat this division sign as just a division sign, just to break it out, and then divided by 6. So I'm just rewriting that complex fraction into something that looks a little bit more familiar. So hopefully what you've noted in past math classes with regards to dividing fractions, you're always going to, with the first value, you're going to skip it. In other words, what I'm saying is you're going to leave it as you see it. So I'm going to leave that as a 1/2. For the second value, I'm going to flip it. So in other words, instead of 6, I'm going to do 1/6. And then from here, we're going to multiply. So we're just going to make that into a multiplication sign. The result then gives me 1/12. So really what this is saying is n raised to that nasty 1/2 divided by 6 thing that we've got going on here. This is saying the same thing as n raised to the 1/12. This then becomes, we can translate this back. So I have a denominator of 12, so I have a 12th root with just an n raised to the 1st power under it, or we can just write that as n. Here is your final solution. So again, this last problem was meant to be super challenging, just to kind of test to see, I guess, like the logical thinking skills that you have, and trying to just push you back or push you down a little bit further into this exploration to hopefully lift you up in terms of your understanding and comfort with the concepts. So if you do have any questions, please let me know, and thank you.